Assalamualaikum, my name is Nukamila Mitizaidi. I will present the first chapter for this project. We conducted the assessment at Day 1 Badminton UTHM. We audited the hall's functional capacity by measuring three key factors such as reverberation time, background noise, and illuminance level. By comparing our data against TOSH and MS 1525 industrial standard, we identified critical gaps that limit the hall's versatility. Based on this measurement, we have proposed technical upgrades to improve sound clarity and visual comfort, transforming the space into a high-standard multipurpose venue. The objective of this project is to measure the current acoustic performance, reverberation time, background noise, and lighting levels within the Day 1 Badminton UTHM. Second is to assess the compliance of these measurements with established regulation, specifically the DOSH standard for noise and the MS 1525-2014 for lighting. And the third one is to propose technical improvement and mitigation strategies based on the collected data to enhance the hall's suitability for multi-purpose use.
Assalamualaikum and hi, my name is Muhammad Faris Izzuddin bin Zulkifli Izzuddin, metric number DF220095. Today I'm going to be presenting about methodology. So basically methodology refers to a systematic process where procedures are used to conduct a study or experiment. In this case, we measure reverberation time, background noise, and lighting measurement. So for the reverberation time measurement, firstly, the sound source was placed at the selected location in the hall to ensure even sound distribution throughout the space. So a total of 45 points were set up using a grid layout with a 5 meter horizontally spacing and 2.4 meter vertically spacing to cover the entire hall. So at each point, the sound level meter microphone was mounted on a tripod with a height of 1.2 meter above the ground, which represent the height of a ear of a seated occupant. To reduce the effect of direct sound, a minimum distance of 1.5 meter was maintained between the sound source and the microphone. All measurement points were also positioned at least 1 meter away from the wall and reflective surfaces to minimize boundary reflection influence and ensure decay measurement represents the room. So the measurement begins when the sound source generated broad noise until a stable sound field was achieved inside the hall. Once the sound field became steady, the sound source was switched off and the sound level meter then recorded the sound decay. The reverberation time was obtained by measuring the time taken for the sound level to decrease by 60 decibels, known as RT60. To ensure a reliable result, measurements were repeated at different source and receiver position. The final reverberation time for each frequency band was calculated by averaging all the measured values. And the second measurement is background noise measurement. So before the background noise measurement begins, all intentional sound sources, including PA system and sports activities, were turned off to measure only the natural ambient source, and the mechanical ventilation system, which consists of 9 industrial fans, remain operated to represent normal hall condition. The sound level meter was placed on a tripod with a height of 1.2 meters, same as the reverberation time measurement, at several locations in the hall. So the background noise were recorded over a fixed time period at each location and repeated at different times to account for noise fluctuation. So the measured data were analyzed using octave band analysis and used to generate noise rating curve, which was compared with standard criteria for multipurpose halls. And to ensure reliability, measurements were taken at multiple locations, and the final background noise level was obtained by averaging all results. So for the lighting measurement, all the measurements were conducted using a lux meter with a grid layout to ensure uniform coverage across the hall. So the sensor of the lux meter was placed at 0.8 meter above the ground, representing a working plane height, and all the lighting fixtures were switched on and allowed to stabilize before the readings were taken. So the measured values were recorded at each grid point and used to generate illuminance contour plots to assess light distribution and uniformity. The results then were compared with Malaysian standard MS1525, is a standard for multipurpose hall, and the final illuminance level was obtained by averaging all measurements.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazir bin Kamaruddin. My metric number is CF220044, and I want to continue the presentation. So as you can see, this is our plan layout. The plan layout shown for plan view. So next, this is our group plan layout for elevation view. As you can see, there are 5 elevation from the badminton hall located at UTHM.
This study evaluates the UTHM badminton hall acoustic performance by measure a reverberation time across 50 precincts. Our analysis showed that the hall reverberation time is fairly critical. We recorded a peak of 144 at the lower frequency. International guideline, the whole 20 seconds of reverberation time is nearly to the 10 time recommended limit. And this creates
Assalamualaikum and hi, my name is Muhammad Muzaffar bin Azmi. My metric number is JF220215, and now I'll continue present about the background noise. Background noise refers to the ambient sound in a space when no intentional sound source is present. It is important because high background noise can reduce speech clarity and affect acoustic comfort. Therefore, background noise assessment is needed to understand the usability of the hall. The overall average background noise recorded in the hall is 44.5 dB. The results show that noise levels are higher at low frequencies and gradually decrease as the frequency increases. This pattern is commonly found in large enclosed indoor spaces. The measured background noise values were compared with the noise rating curves. Most of the values fall between NR30 and NR40, with low frequency noise being the dominant component. This indicates that the background noise level is generally acceptable for this type of space. In conclusion, Dewan Badminton UTHM has a moderate background noise level and is suitable for sports and multipurpose activities. However, additional low-frequency noise control may be required if the hall is intended for acoustically sensitive uses. That's all from me, thanks.
So for the analysis of illuminance, an analysis of illuminance level at badminton hall UTHM was conducted to evaluate the adequacy and distribution of lighting within the facility. The result obtained are present and discussed as follows. First, for the area, the total area is 151.06 meter square. For the total luminous flux, 1.233,600 luminous. For illuminous level lux equals to total luminous flux per area. So for the total of lux is 1,297.08.
The hall currently has a massive reverberation time and making a speech unintelligible. To fix this, our acoustic improvement plan start by replacing. To modernize the hall, we are upgrading the high efficiency LED to achieve a 500 Hz for exams and high color quality for a ceremony. First,
In conclusion, the hall is acoustically live with a reverberation time of 20 seconds, which is nearly 10 times the recommended limit. We also recorded a significant bass boom at 80 Hz and lighting that, while bright, lacks the uniform distribution needed for formal events. To resolve this issue, we proposed a two-phase upgrade. First, installing acoustic panels and bass straps to fix sound clarity. Second, upgrading to a layered LED system with DMX controls to allow for adaptable lighting modes. This targeted data-driven modification will transform the facility into a high-performance professional venue for the entire university community. That's all for our group. Thank you.